Welcome back to the Building HVAC Science Podcast, where we are spending our time to connect people with ideas, technologies, things to benefit their daily work and their lives. In this episode, Eric and I welcome Amit Gupta from AeroSeal. This is a company that specializes in duct sealing technology, in case you haven't heard about them. Amit shares with us the backstory of AeroSeal, which was found based on a technology invented by Dr. Modera at the Lawrence Berkeley National Lab. The technology struggled to gain traction under its first ownership, and then Amit saw the opportunity for significant energy improvements in homes through duct sealing. And his passion for the technology led him to acquire and then reboot AeroSeal as an independent company in 2010. This company focuses on sealing ducts, building envelopes, and potentially underground pipelines. That's some news to us, as we learned on the podcast. The technology addresses the inefficiency and energy loss in buildings by sealing air ducts and the building envelope with a patented process that injects micron-sized particles to seal air leaks from the inside. Now, this approach, Amit likens to fix-a-flat for buildings, and this should significantly reduce energy waste and contribute to net zero energy building goals. He highlights the vast potential impact of the technology, noting buildings contribute to a significant portion of CO2 emissions and energy consumption, primarily through heating and cooling of the buildings and houses and homes. Now, by improving the sealing of ducts and the envelope, the shell, AeroSeal aims to address this inefficiency systematically, offering a solution for both new construction and existing buildings. Our conversation, as always, we kind of dig into it, and it touched upon the challenges and opportunities for promoting AeroSeal's technology. And we discussed the common acceptance of inefficient HVAC systems by homeowners. They just don't know. Sometimes they don't know that the discomfort and the energy bills are caused by the shell or the duct leakage. And we also have a gradual shift in the industry towards recognizing the importance of energy efficiency and combined with that indoor air quality. This technology's application ranges from residential homes to iconic commercial buildings, which we discuss, and we can see in it the scalability and effectiveness. It seems like magic, but it really isn't. It's just great physics and chemistry. Amit emphasizes the importance of action and awareness in adopting such technologies to make a tangible impact on the energy efficiency and environmental sustainability. Okay, we've done our part. We've taken action. We're trying to make you aware. Listen to this, take a look in the links in the show notes, and bring yourself up to speed on closing the gap. That's AeroSeal's quest for net zero buildings.
I am Eric Kaiser, and with us today, of course, is Bill Spohn, my co-host, as well as Mr. Amit Gupta from AeroSeal. Welcome, sir.
Thank you, Eric. I'm glad to be here.
Amit, good to see you again. See you at many trade shows over the years. I think you have a very interesting backstory to where you got to today. And if you care to share a summary of your experience, which led you to be the president and leader of AeroSeal.
Sure. So the history of AeroSeal and the start of AeroSeal. So when I started this company in 2010 September, I call it AeroSeal 2.0. Originally, the company was formed, technology was invented by Dr. Mark Modera at LBNL, and he sold the company, or Carrier acquired this company in 2001 from him. And as sometimes happens, very promising technology in large corporations sometimes don't get the right attention, or the business structure doesn't come out to be very appropriate. It didn't make as much progress at Carrier. I joined Carrier after my MBA, and I was running different product lines at Carrier as product manager, and AeroSeal was one of them. And I could immediately see the potential of AeroSeal. At that time, we only had one solution for air duct sealing. And Carrier was investing a lot of money, tens of millions of dollars, to make their furnace another 2% more efficient. Or there was lots of conversation from going from 13 SEER to 15 SEER or 14 SEER, the next DOE change outcoming. And here I was looking at a solution which could improve 20-30% efficiency in every home because ducts just leak. This is established fact. that ducts leaks from 20% to 40% if you count return and supply ducts in most homes in US. Air ducts were established to be the single largest culprit of energy wastage in US homes, like 540 trillion BTUs. And nobody was addressing that issue. No one. I got really passionate about it when I got to manage this company in 2009. We tried to make it work within Carrier, lots of conversations. There were some business issues with inventor Dr. Modera and his partner, where there was an earn-out. So there was like business issues. Ultimately, we were able to take the company out of Carrier, where Carrier got access to the technology. And we took all the business structure which Carrier had with Dr. Modera and his partner and restructured it and restarted the company in 2010 September, almost bootstrapped the company. So that's how it all got started.
Wow, that's pretty neat because I was still under the impression it was with Carrier.
No, we have been an independent company since 2010.
Were there any major changes? And I know you've got two basic products, the AeroSeal and the AeroBarrier, correct?
That is correct. So let me give you a little bit of what technologies we have and where we see our vision or the role we play in the world. So we have now 3 technologies in the company, which one is for air duct sealing. The second technology is for building envelope sealing. And third technology is underground gas pipeline sealing. So the concept of creating a controlled environment of pressure, temperature, humidity, whatever we want to say, and then injecting few micron-sized particles, different chemistry, and using that to seal the leaks or the wastage, the concept is similar, but we have 3 patents, and these are worldwide patents from China to India to Europe. So that's the technology roadmap of our company. It has evolved from 2010 to now. And the 2 technologies we have commercialized, which is for air duct sealing and building envelope sealing, and the underground gas pipeline, which can also be used for compressed air systems and industrial application, that is still under development. So that's the technology piece of our company.
I liken the product in some ways in my mind to like when you cut yourself and things seal from the inside with the platelets in your blood. Is that an accurate analogy?
Yes, but rather than sharing an image of somebody getting hurt, we call ourselves like a fixer flat for the buildings. So our mission is actually making all buildings worldwide, enabling the buildings to be net zero. We cannot have a net zero building without wasting such large amount of energy from the building. It just doesn't make any sense. And I'll give you my thesis. And we now have really top venture capital firms who are now part of the company and invested in the company. And our thesis basically is that the world of all the energy being produced or all the CO2 emissions in the world, buildings contribute 40% of that. And close to 50% of what building is consuming in energy goes into heating or cooling the building. These are rough numbers. So it could be 47%, somebody says 37%. Different region is different, different part of the world is different. But big picture, 40%, all CO2 emission, all climate bad things happening is contributed by buildings. 50% of that is in heating and cooling. So now we are 20% of all CO2 being produced. Now, of that, 50%, which is 10% of the world's emission, is due to wastage of how the buildings are constructed. So buildings have leaks all over the place. US homes are notorious in some way, and UK, only in Europe, UK homes are made even far worse. We just leak the heated and cooled air from ducts and from building envelope. So our thesis is that there's nobody else in the whole world addressing this problem systematically, not only for new construction, but also for existing buildings, other than what we are trying to do with our technologies. So that's a huge mission statement for us. We really want to enable every building, new or existing, to be net zero ready.
That's a pretty big number when you're talking about 10% of the entire energy usage in the world is due to air leakage in structures?
This is just very rough number. You can come up with a number and say, okay, we did a calculation with a venture capital firm and they had analysts do this work. They said we can at least reduce close to 1 gigaton of GHG emissions. So we can say anywhere from 2% to 6%, various estimates. And my simple way of saying got us to 10%. So somewhere in that range, still a very, very big and a meaningful number.
So how does this differ from the way things are done, alternatives? Say if someone does recognize they do have either envelope leakage or duct leakage or even pipe leakage, what are the traditional methods for accomplishing those repairs or improvements?
So the biggest challenge is, I'm going to give an example of a building. Every building, every house, every situation is different. But imagine you're sitting in a big commercial building. Where are the ducts? Ducts are behind the walls and behind the ceiling. There is no other way in the world to practically go and address the leakage. And the building codes have evolved over time. The buildings built in 1940s, I bet you did not require the ducts to be sealed and did not require the efficiency from the buildings. But once built, there is just no way. Nobody's going to break open all the walls or take away all the ceilings, because the cost of getting to the leaks and then hand sealing them, which is the only other alternative, is prohibitive. So nobody addresses it. So the alternative, answer to your question is hand sealing. You have to physically find the leaks and then physically apply a tape or a mastic or a caulk to seal the leaks. It's still a very primitive way of doing it. That's the alternative. And in our case, as I say, we are the fixer flat for the building. So you just pressurize the building, inject this safe micron-sized particles, a few micron-sized particles in the space, and they automatically finds all the leaks. And as they try to escape the leaks, they seal it. So that is so much simpler and so much more easy to do.
I just want to ask a question here because I heard you mention this fix-a-flat, and I've taken apart a couple of tires with fix-a-flat in them. And fix-a-flat is messy. So I want to know, is this as messy as that green goopy fix-a-flat that comes out of my tire?
No, really not. So this is, in a home, we could get the work done in the sealing time is like 35 minutes, 40 minutes. Of course, we have to prep it. So we have to block off all the vents. Then we attach our machine, which has a fan. So it pressurizes the ductwork. And then we inject the sealant material. And it takes 25 minutes, 35 minutes to seal up all the leaks in the ductwork.
And I've seen some of the either videos or seen it done where you can actually monitor the performance improvement in the duct as you're going.
Absolutely. So this is a software controlled process. What I just mentioned, how we do it, like pressurize and inject and we seal, it sounds very, very simple. But the algorithms which goes into making it work are not as simple. We are creating an environment by controlling the temperature, the humidity, the pressure, the airflow, etc., where the sealant material is going only to the leaks. It's not sticking to the wall. And the sealant material is able to work in, whether it's raining outside, whether you're in Denver, or whether you're in a high humidity area, or in the middle of Arizona, or you're in Alaska. So the algorithms are really, that's our secret sauce to make the process work. So it's not that easy. And we have various sensors built into the machine. And all of that is controlled by software. So the technician and the homeowner or the building facility manager, they could see it on their phone or on computer screen that what was the initial leakage, how much wastage they have, and minute by minute they can see how much wastage they are reducing. So we print out a certificate for the homeowners or the facility managers to say, okay, we saved you 2 tons of air of the system, or 30% improvement in efficiency improvement. Or when we work with builders, when we do the building envelope, we can give them a certificate which they don't have to worry about at the closing when they're doing a blower door test. Is the house going to pass or not pass? It's an automated but highly sophisticated process and we've guaranteed the work produced by our system and our trained technicians for like 10 years.
That's a pretty good life. What's your life expectancy on the product then beyond the 10 years? Is there a life expectancy you have on that?
We believe it's got any building material life expectancy, right? We have tested it for like 40 years, but we don't know exactly when it fails. But we know that it lasts for a very long time, and we guarantee it better than most people would guarantee, even caulk, that it'll last.
Is there some limit to the size of the break or the hole that it can fill?
Yeah, so for duct sealing, we can fill up to 5/8 of an inch. So almost you can see a dime. For envelope sealing, it's half an inch.
That's still pretty good size holes.
Yeah, so half an inch is a pretty standard way of looking at it that we can take care of. Most of the leaks are small. In the ductwork, there is a bend in the metal where there is a slip drive, or these are small leaks, but lots and lots of leaks. That's what creates the trouble.
Yeah, it's trying to seal up a flour sifter or something like that. It's small holes, but a lot of them. And when you add them all up, it creates a big leak.
Right.
Is there something in the material, as I seem to recall it, when it hits an edge, it sticks?
That is correct.
Can you describe that process and how it aggregates?
As I said, in a very controlled manner, all through as a software, when we inject the material in any controlled space, the material is floating around. When it encounters a leak, there is a pressure differential from the inside and the outside of the leak. So the air tries to escape. It's almost like when you have a prick in a balloon, right? The air tries to escape from it. As air tries to rush out of that hole, the particles get carried with that air and try to rush out. And when that happens, you can almost imagine that a particle which is taking a sharp turn, and the centrifugal force of that turn hits the edge of the leak, and the second set of particles hits the first particle, and then very soon it forms the seal. That's the simple process. It's the physics, how we seal the leak, not the chemistry. People think it's chemistry is having the right particles and the right particle properties and the safety profile of the particles. That is chemistry part. But the sealing part is more physics rather than chemistry.
Got it.
Very neat.
You had mentioned earlier a trained, certified technician. Talk about how this is deployed into the world.
So we are a technology company. We developed this technology. We are constantly improving that technology, of course. We have partnership with HVAC dealers. We have partnership with installation contractors. We have partnerships with mechanical contractors, and our machines are now available in 32 different countries. When a mechanical contractor or HVAC contract like Williams Air in Indianapolis is one of our dealers, they would buy a machine from us, and now we can even lease the machine for the right contractor, so they don't have to make a capital investment. And they take our machines, and when they go to the homes or when they go to the buildings, they offer this service to the homeowners. And when they're installing high efficiency furnace, or in today's world, everybody talks about heat pumps, that heat pumps are the climate solution. Heat pumps do not work and cannot work very well without good ductwork. Without weatherization, heat pumps are actually going backwards. So when our good contractors who we have trained, when they install these equipments or as a separate service, they bring these solutions to the homeowners or the building owners. So that's how we go to market.
You've talked some about homeowners versus homes versus commercial buildings. I'm guessing from that you're getting into commercial. Is that how big of a system can you realistically do with this? How much duct surface, or I guess, do you go by the total CFM move through a duct system?
We can do, we believe, any size of ductwork. It's a matter of being able to pressurize. We just did a ductwork in California, which was a size of, it was a special purpose duct, like 10 feet by 12 feet and probably 20-story high or something like that. It's a matter of creating enough pressure so we can attach multiple fans to create a pressure, and then we can create enough in particles. And of course, our software calculates all of that to create the right conditions for us to be able to seal it. We have done very large buildings, some iconic buildings like MetLife building in New York City. That's like a 3.2 million square feet building. We have done big shafts in that, air shafts where you can literally drive a car into. We've done those. What other buildings people would be able to recognize? Like Wynn Hotels in Las Vegas, we have done those, both Encore and Wynn Hotels. So many, many buildings. And you can think of a large building and we have done something similar. Big hospitals, we have done lots of hospitals. It's a really good place. Lots of hotels. We have done big Marriott hotels, biggest Hilton hotel in Saudi Arabia, the tallest buildings in Dubai. I mean, I can go on and on. If there are iconic buildings and people want to do good work, they probably would have used our dealers or our technology.
Yeah, it sounds like there's not much that this can't work in then. That was where I was wanting to know is what are the limitations on that? Because when we think about, oh, it'll work great in a house, that doesn't always transition to working great in a giant, large duct.
Right.
What are some of the challenges you're facing in terms of getting more people to look at this technology?
People have gotten used to living with the problem. They have hot and cold rooms, and they're like, yeah, this is how the house is built. Or they would put a heater in their kids' room or humidifiers in their kids' room because my kids had nosebleed. So, first idea or instinct is to put a room humidifier. So, people have started to gotten used to it. Yes, like a lot of people have allergies. They don't see, okay, why are the allergies coming to my house? They have dust, like in southern market. You build really good homes, you should not have those problems. So that's one of the challenges. And more people are realizing that, hey, it's a simple fix. If you have a whole house humidifier, you shouldn't need a room humidifier. If you have a central system, you shouldn't be putting room heaters in various rooms. You shouldn't be uncomfortable in your bonus room. That awareness is increasing. That idea is becoming, it's inefficient. It's creating, not only the HVAC system is inefficient, it's just leading to more inefficiency because people are now compensating for it. So that's one challenge. And then the other challenge is this policy work which we are working on. Heat pump has such enormous push from the policy point of view. The many cities, many municipalities are not even allowing natural gas to be run to those homes, new homes being built, because heat pumps are the issue. And we are trying to overcome or bring the complete solution to them that heat pumps with electric heat is a bad idea if the heat pumps don't work very well. The temperature coming out of the register for heat pump is probably 10, 15 degrees lower than furnace, temperature of the air coming out of furnace.
Depends on the heat pump and the furnace, but yeah.
Right. But significantly lower.
A lot lower.
Lot lower. And on top of that, if you have duct leakage, you probably have another 7-degree drop. So duct leakage creates that issue or exacerbate that issue. And then people feel cold blow, and then people don't like heat pumps. So the adoption of heat pump is bad. And then on top of that, since the capacity loss happens with heat pumps, then when heat pumps can't keep up, the electric heat comes on. That's far worse for the climate. It takes us in the opposite direction than what we're trying to do with heat pumps. So bringing that awareness with the policy, that's another challenge. And I'll mention one more challenge, which is the home builders. General with the adoption by states for energy efficiency codes, the IECC codes of 2015, 2018, there are still lots of states, and it feels bad for me to say that, but in Ohio, we don't even have a requirement for envelope sealing. I mean, you can literally build a home, and we have done lots of homes which we have sealed, which are at 10 air changes per hour. Imagine 10 air changes per hour, which is every 6 minutes. How could you have a comfortable and a healthy home with that? And then builders think that, and we are changing that, to make a better envelope is super expensive because they have to caulk everything and they can't hold their trade responsible for it. And if they have to test it, their time to build the home is going to increase and the cost is going to increase and blah, 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 right? So that's another challenge, which we are working on, making builders more aware. We are making policy people more aware that we have an easy button. That technology is coming and bringing solutions to perceived issues in the world of construction. So those are the three challenges I would mention.
This idea of getting used to the problem, I've heard this before in a lot of ways in the home performance field. The analogy that I heard one person give, it's you have a car that was built 10 years ago, you drive around all the time. Then you go on a business trip or you go on any trip, you rent a new car and you look at the features and you've heard about these features, but you exist within those features and you go, I want that. I really didn't know I could have that. It's a different experience. So I've always thought that, is there a way to get some demonstration performance house into people's rental homes or Airbnbs or VRBOs and give them an AeroSeal Gold Star experience and have them come back and say, I want that. I'd love to see that happen.
Absolutely. It's changing though. With IRA, I believe builders are incentivized to build better homes. And I think it is changing. And younger generation, new homeowners are more aware of their carbon footprint. They at least are thinking more about it and they're thinking beyond the granite countertop. I mean, I'll mention Beazer Homes. They have a commitment to build net zero homes by 2025, next year. And we are a big partner of them for doing that. Manley Homes, which builds net zero ready homes, we are a big partner of them. So many builders are making us as a standard. So at least the new homes are coming more and more with better standards. More builders are building those. So I'm very optimistic.
Yeah, it's good to get these verbiage into the conversation, to get them displayed by leading builders, which will lead to consumer awareness. How about on the commercial side? To me, it's more of like a matter of fact thing, like energy savings. So I'll look in the commercial side.
So the way we are approaching the commercial side is we work with ESCOs like JCI and Honeywell. We are bringing these solutions to universities and hospitals. We're trying to do it by get some scale rather than have the sales cycle by each building owner. So those are the two approaches we have taken. We work with hospital groups. So like Steward Health, we have good partnership with them. We've done few hospitals for them and they have 30, 40 hospitals, which we are going to do all of them. And that's a big focus. Healthcare industry, the fresh air requirements they have, their energy footprint is really, really high. So we make a big difference in that. And then we have focused areas like New York City, where the local law 97 creates enormous incentives and penalties, or carrot and stick both, right? With utility rebates as well as penalties coming for building owners to make dramatic changes, or at least move the priority of all the things they're doing a little bit higher for this work.
I have a question going back to the third technology you mentioned, which was the pipe sealant. Can you talk about that much?
It's still under development, and there are a few things we are still trying to be careful about divulging. So we have proven the technology works, and in the labs, we have some field trials we have done. We have Aramco, one of the biggest oil company, as one of our investors now, and the top venture capital firms who are now part of the company. Aramco is one of them. So I see that we will put our focus on it, and a product should be there in 2025, if not 2020, middle of 2025, if not 2026. And rather than gas pipeline, we might attack the compressed air systems first.
A lot of energy wastage there.
Yes. In IRA, there is like a $7 billion, and they talk about specific initiatives for reducing the methane leakage. These infrastructure is old and underground. There's no good way to address it. I mean, it's there. So we just live with it. It just seeps into the ground and it just creates a huge impact.
Or gets into the air, yeah.
Right.
The only way is to either dig it up or you sleeve the inside of it. But if you sleeve the inside of it, then you reduce the diameter to the point where
your flow is impacted.
Yeah, your flow's impacted unless you drastically raise the pressure, and they don't want to do that on a lot of the lines. So that would be a neat product to see.
I've heard the sleeving part for sewage pipes. I've not heard in gas pipeline that they're putting the sleeves, probably in some bigger diameter pipes, but not small ones.
Yeah, not in the small ones because it's such a percentage reduction.
You're right.
So if we've intrigued or interested listeners by this conversation, which we hope we have, that's our goal to do it, right, Eric? That's what we try to do all the time.
We're intrigued, so we hope everyone else is too.
What's the follow-up, and let's say for different classes of listeners? So for the consumer, what's the follow-up? For the interested contractor, what's the follow-up?
Go to our website, www.aeroseal.com, AeroSeal.com. Send us a request. You can call us too. We'd love to bring this solution to you. We feel that everyone could benefit. There are very few things in the world where we can make a dramatic impact without making a big behavioral change. All you have to do is fix the ductwork. You not only get a significant benefit in comfort and air quality in your home, you can improve the health of your house, but also it'll pay for itself. So there are very few, I don't know of many solutions which can claim clearly impact all three. We would love to work with builders, homeowners, engineers. Reach out.
The biggest behavioral change you're asking for is people to move into action.
Yes, that is correct. And that is the hard one too.
That's the hard one too, yeah. But once they've heard this, it's got to be interesting.
Start with awareness.
Are there any closing thoughts you'd like to share with our listeners?
First of all, thank you for the opportunity, Bill and Eric. I appreciate it. Good to see you guys. And in closing, all I can say is that we can make a difference. We can make a difference. We all have to play a role in the world we are creating. It's not the world which just exists. We are part of creation of the world for our future generations, and we can be a little bit responsible about it. And I'm not asking responsibility from people to do a big change. You can have a short-term gain now, as well as have a long-term benefit. So some of those examples and some of those solutions are right in front of you. Action is what we need. So action is what we must take.
Now, we have coming up the AHR Expo. What is your engagement with AeroSeal at the Expo?
Absolutely. We have a big booth there. I don't remember the booth number, but we would love to see people there. And we will be also at IBS, International Builder Show. If people want to come and engage with us there, we'd love to have you there as well.
Perfect. Eric and I, one or both of us will stop by and see you.
That would be awesome.
Well, it was a pleasure to have you on the podcast today. I mean, it's always good catching up and love hearing the progress and growth of your company.
Thank you. Thank you for the opportunity. It was good to see you.
Take care, everyone.
Thank you.
Thanks for tuning into this episode of the Building HVAC Science podcast. We're trying to do our part in helping the professions of HVAC and building performance better understand each other and work together with the ultimate goal of creating safe and comfortable and environmentally efficient spaces in offices, buildings, homes, etc. I also host the Res Talk podcast, and you can learn more about what's happening in the home energy ratings and all those peripheral topics. If you want to reach out to this podcast, you can send an email to marketing@truetechtools.com, TRUTECHTOOLS.com. Some of the topics we discuss require technical training for proper interpretation or safe execution. So if you're a trained pro, go ahead and do those activities. And if you're not, please consult with and hire a pro. Also, take a look at the betterhvac.org website if you're a technician, betterhvac.org. That's a new movement I've become involved with, and I'd like to get some other people on board. Drop me a line if you have any comments on that. You can email me directly at bill@truetechtools.com. The opinions voiced are those of my guests or my co-host or myself, depending on who is speaking, of course, and the Building HVAC Science podcast, a production of True Tech Tools Limited. In full disclosure, I'm a co-owner of True Tech. Thank you for following and listening to this podcast, and if you're in the market for tools or test instruments, you can take a look at True Tech Tools, my company, TRUTECHTOOLS.com, and use the offer code HVACBS for a nice discount. Again, appreciate you lending us your ears and your brain to learn more about this topic and closing the gap, AeroSeal's quest for net zero buildings. Take care until next time. Bye.